And from each of these sides, I learned some stuff. So it helped me to have the complete idea about what's happening really in the building from all these different aspects. So please feel free to stop me anytime and ask any question you want through the presentation. And from here, we start the conversation with why this matters. Three numbers to anchor the whole session. The first one is building consume 40% of the global energy. It's not transportation, it's building. Second number is all of the data currently we are having in BMS system or access control or fire. 90% of these data, nobody touch, nobody use. It's an untouched data. Third number, once we put AI on top of a properly integrated BMS, operators see 3 times the operational intelligence. Not 3 times the hardware, just the same hardware, but being listened to. And with currently the local angle and the regulation in the country or in the region, which make green building compliance mandatory. It's not option. And saving energy is mandatory because cooling drives the majority of the building energies. So imagine that a 2% saving in the cooling is representing almost 1% of the global energy consumption. So it's a huge number. To understand why AI changed the equation, let's see how we got there. The journey of the control, it started with the basic automation, which was from the 80s to the 2000s. With basic automation, it was a matter of switching some P&ID loop, scheduling, alarming, useful, but it's a dumb. A system in the sense of it does what you told it to do, when you told it to do. From the 2000 in roughly to 2020, we brought integration. Everybody started to speak about .NET, about integration, about use cases. And connecting HVAC to fire security over the same one network instead of having separate isolated islands. That's straightforward, but still, the building will follow what you told it to do. And then what we are having now is the generation 3, is where the platform starts to learn, predict, and optimize its own. The main takeaway here, we cannot skip to generation 3. AI on top of generation 1 is just a faster managing the isolated island. It will not help us to go anywhere. The foundation is to having an integrated platform, a generated system. Sorry, any question?
Okay.
Any question?
No, it's okay.
Okay, perfect. So the foundation has to be starting with generation 2 before going into the intelligence. So what does generation 3 actually look like? These are 6 AI building today. It's not a lab experiment. I'm not speaking about the future. I'm speaking about real use cases that can be implemented right now. And it's already installed and implemented in multiple facilities. Fault detection, catching a failing component before the alarm even fires. This is happening through AI analytics that run and digest all the data extracted from the DMS, analyze the slight change in the temperature, in the vibration of the pump, in changing the temperature of the oil in a chiller. Um, what happened with a slight change in the PICV valve in the AHU and how it's reflected in the supply temperature from the air handling unit and even the room and the facility temperature. All these slight analytics, it can detect a fault in any part of the system before it even happens. Predictive maintenance, serving equipment based on actual condition, not a calendar event that might be 6 months too late or 6 months too early. Actually, this can make a huge difference of how you run your facilities. Because having this immediate failure in an equipment that it was supposed to be maintained after 2 months, but out of we are having some peaks, we had this failure happening now, not after 2 months. So having these kind of predictive maintenance intelligence, it will help us to deliver a smooth experience to the occupant of the building. Also, occupancy optimization, HVAC and lighting that follow where people actually are. It's not a fixed schedule and it's working as per demand control, either demand ventilation or demand lighting. So we will never go to a mall and find a part of the mall is overcooled because there is nobody in this part, and another part of the mall it's crazy hot because there is a lot of people and congested area in this part of the mall. So the system will start the analytics and based on the real demand and the real crowd, it will start modulate the air handling unit to assure saving energy and delivering proper comfort to the occupants. Energy forecasting, predicting demand and shift load ahead of the peak, which matter a lot when you are paying peak tariffs. Also, anomaly detection, flagging pattern across system that no single system would catch on its own. Getting data and analyze it from multiple systems. Like, for example, if we are having a pattern that whenever this crowd happened from the analytics of the CCTV about the number of people, whenever this crowd happened in that part, it will lead to increase of temperature, it will lead to a demand for the air handling unit and then a demand in the chiller. So connecting these puzzle, it will never happen in one system. It should be one system, digest all the data, analyze it, and then this system will start detect these patterns. Also, anonymous response, acting on the inside directly with no human requirement in the loop. Like, for example, self-test smoke detector. Start using the AI to check the valve either in the non-peak hour to open it fully and close it fully and assure that the actuator is performing good. These kind of regular maintenance, which used to waste a lot of manpower and sometimes money and sometimes closing area and some critical infrastructure, to just to check if the smoke detector is running or not, or fail or not, if the temperature sensor is in a good condition or not, if the actuator can open and close normally or if having any problems. These kind of self-check, it can change the overall experience of running the building. And again, none of these are just words. All of these are real time can be delivered and it's already working in some project. And none of this can work at a standalone. This is what I really want to set from this slide. This is the integration backbone of every single system. This is the single line view of an integrated architecture which deployed in multiple facilities in the Gulf. At the top, there is a command and control center, central management system, in a single pane of glass that can monitor, control, manage the alarm, trends, report, remote access and operation, analytics, API integration. It's one system, one network, instead of multiple systems in separate isolated islands. This is what makes everything possible. Any questions so far? Okay. So there is a lot of use cases coming now out of analytics and performing intelligence between the integration of these buildings and having one enterprise software managing all these hardwares and solution. And more than this, it's not a lab environment. It's already running experience in multiple projects. There is a lot of projects that having all these systems and much more. And from this integration, we can start thinking a lot of use cases. And these use cases, it will start to digest data from a system, taking action on another system, doing analytics on multiple systems, and start taking action on another system. Let's say, for example, if we are having a mall, and from this mall, the CCTV system with the analytics, it can analyze which area of the mall is overcrowded and which is not. So the scenario we just mentioned a couple of minutes back, it will never happen because out of the exact amount of people, we're gonna start to controlling the HVAC load based on the number of people in each area of the mall, delivering an exact demand cooling ventilation. So we are not overcooling the mall. Nobody will go to the mall and he will get freezed because this area is overcooled. And in the same time, the client will not pay that much of money for energy that nobody is using and people are complaining from getting cold. So we are losing here that the client is paying extra money and the end user is overcooled and he's not even satisfied. So we are losing on both sides. Another example about using RTLS. Let's say, for example, in an hospital where instead of the nurse call, if we're having an emergency in the reception, so the nurse call system, it will send a random notification asking for a nurse. He will choose any random non-busy nurse. But if the RTLS is connected to the nurse call system, so the system, the enterprise software, it will know exactly the location of each single free nurse. So the nurse call system, it will not choose the nurse randomly. It will choose the most close nurse. So we optimize the workflow. In the same times, if the system having the asset management system within the connection, so if the nurse needs to get any device, it will give her an exact notification that go to this room, pick up this device, and come to the reception. If the system is connected to the access control system and the CCTV, so the camera will detect the nurse location, and based on this, the access control will start to automatically unlock the door in her way. And with that, you are saving in each minute of this step, you are saving like 1 minute here, 2 minutes there, 1 minute here. In the check of an 8 hour, you can easily save 30 minutes, which is, we are speaking about 5% of the utilization of a single headcount. Think about monetizing this. So you can easily operate your stuff much more efficient, easily by 5 to 10% by this, without installing a single hardware. It's just about software orchestration between these systems, which you already have in the facilities. We are not installing any hardware. We are just maximizing the use of all the hardware through a unified software platform. Any questions so far? Okay. So let's back again to the scenario of the fire that we spoke in the beginning of the talk. By implementing these structure, so the fire alarm will act as it's acting as per the regulation, but at the same time, when this happens, it will be automatically sent to the DMS to shut down all the required air handling unit and fan coil unit. You will identify exactly the location. No manual confirmation calls are required. The system will automatically stop air handling unit and fan coil unit, and it will start the exhaust fan, open the fire dumper, activate the public address, unlock the door from the security system. All these 5 actions, it will go simultaneously, automatically, without the involvement of humans. And based on this event, in the first case, you can never assure that if this floor already evacuated or not. But if the CCTV is integrated, you can already assure this. If there is someone trapped, you know exactly where it's trapped because of the analytics in the camera. You can start using the analytics to count people, using the analytics and open the access doors in these spaces, guide the people through the public address and voice evacuation. And all this happening orchestrated with no human interaction. Compare that to where we started the talk, about 90-second calls and manual action versus this, which happened before most of the people in the building even know that there is an alarm. This is part of the gap that AI and the integration plays. And this is already available today. Any questions?
Regarding the questions, we will keep it the last because it will be disturbed in the
Okay.
middle. Yeah.
Okay, sure. So let's keep the dramatic example of the fire and speak about a quieter one that change how we design and operate the building. Digital twins. So this is the second buzzword after AI. Everybody's speaking about AI and digital twin. So what is a digital twin? A digital twin is a live virtual replica of the physical building, and it's actively fed with the same data we have been talking about. The physical side gives its sensors, measurements, real occupancy data. The digital twin part gives you a back simulation and prediction. Practically, that means four things we care about. We can test change before you touch live equipment. So, for example, we don't need to, if we need to, what will happen if I slightly change the set point of the chiller from 6.5 from 6 degree to 6.5 degree? What will be the effect of this on my building? So I don't need to make this on the real building. I can run it on the digital twin and get the result reported and measure the outcomes. We can model energy performance. We can predict the commissioning issue before they become a punch list item. We can simulate retrofit to see the payback before we spend a single dirhams. So for NLP specifically, this is the tool, the term we think that this will work into. We ran it, we deployed it, and these are the measured outcome. So it's changed the philosophy of design, that it will not be based on assumption, because all the calculation will be based on real data from the building itself. So all of this sounds so clean and so easy and so doable. So let's talk about where it gets hurt and what is the hard part about it. So what is the challenge and real obstacles of the solutions? We're having mainly four obstacles. So I will go through each one of them. The first problem is protocol fragmentation. As we used to have different specifications for each different software and system, so we're gonna have a scatters protocols, Modbus, BACnet, Linear, KNX, whatever, sometimes CPAS, MPAS, and sometimes we're having protocol coming out of different era, which is nobody is using right now. And the fix is not replacing and ripping everything out. Now, in the market, there is a lot of coordinations, gateways, sometimes API integration, and device that can convert protocol into a unified API. And this can solve this problem totally. Second problem is the concern of the cybersecurity, because with every single client, he will tell you, yeah, my IT having the cybersecurity and we are fine. But when we are speaking about the MEP world, it's not about IT cybersecurity, it's about OT cybersecurity. Because at the end, all of our controller is for the VMS, for the lighting control, for the access, for the sound, for the fire alarm. All these panels, they are having IP ports, and these IP ports are considered threat. The moment this system is connected to IP, it's an attack surface. And this should be considered, and assuring through the specs that all these devices should be equipped with a cybersecurity on the IT level, on the OT level, not the IT level. The first point is we're having a lot of data without context. Millions of data points and dashboard nobody looks at. Here, it's not about having more data because already you're having the data. It's already about applying machine learning composer and AI analytics and workflows to get use these data and turn these signals into decisions. And lastly, the skill gap. The technology is going so fast, and there is a lot of tools and tons of data. The engineers who got ahead this decade are the one who's not only fluent in mechanical or electrical, no, we should also consider be a data guy. I'm flagging these because anyone who tells you this, yeah, this is a plug and play, this can manage your entire facility without any issue, who's selling something which you never will. Or simply, if we are not having these four major issues in mind before kickstart any project, at the end, we will have a communication failure, we're having a coordination issue, and mostly the integration and the workflows will not happen. Which brings me to a conclusion here that most EMS platform right now are like gym membership. People fully paid, barely used. And everyone tell that I will start in next quarter. We spent 2 decades installing trillion system and 1 decade using it. AI will not change this. It just make the unused 80% of the data more valuable because it's embarrassing that we are not using it. And again, I don't want to say this is a theory. It's already running right now in the region. There is a lot of use cases on multiple vendors, and these are already running in the region. These are 3 use cases from 3 different projects, 2 in Dubai, 1 in Doha. So the first one is that the grid predicts its own failures. Vua is running AI crushes 15 million data points to assure that it's catching failure before that happens. In the Expo Pavilion, it makes its own power. It's net zero by design, not by offset. In Doha downtown, they are managed the trash system without a single interfere from a human and without any trucks. So already this kind of intelligence system is in the region and working. So let me leave you with main 5 points I want to highlight. That DMS is no longer control. It's data, intelligence, and analytic platform. It's not about managing only HVAC. And coordination between mechanical, electrical, light current, MEPs, it's a must to assure that the specification is tight and the specification is really calling for integration and calling for the value the client is looking for. Second point, AI deliver measurable values on a solid BMS platform foundation. So if you are not having a solid integration and a properly integrated system, the AI will not make it smarter. And instead of having a slow isolated island, you will have a fast isolated island. But at the end, you will not gain the value of having an AI on top of the use cases. Third point, integration and analytics and sustainability now are core. It's not a luxury and it's not cherry on top of the cake. It's a mandate now by regulation. Fourth point, NLP engineer in 2030 is 50% engineers, 50% data scientists. So it's really, we are having a huge amount of data we need to use. Finally, project we designed today define performance for 20 years. So we need to design better building, less energy consumption, because we are consuming 40% of the global energy consumption. I'm done with here about talking. I'm willing more to hear question, but before you start the questions, I will tell you one use cases I worked on with one of the developers here in the region, in UAE actually. This developer, he's having BMS in every single building. And after this, we worked on extracted all these scattered building management system data into one unified software. And out of this, he started to compare the performance of the air handling unit and chiller between all these buildings. And out of this is in the next project, he's having more data to compare the chiller performance, the air handling unit performance. So for next project, I'm not only selecting vendor based on price, I'm selecting vendor based on the performance of his equipment in my building. So I'm not going blindly to the negotiation and I'm not choosing either X chiller or Y chiller based on the price only. No, I'm choosing based on the data I already have. I'm having like 50 buildings. These 50 buildings are running with multiple chiller manufacturers. I can compare the performance. I can compare the spare part price. I can compare the how often I need this spare part. And I can make a real projection what will be the real cost for this chiller for a 20 or 30 years. So I'm not choosing based on the price today. I'm choosing based on the price of the capex and the opex as well. So I'm open for question now. These are my contact, and I'm always happy to dig into real project with you guys. So please feel free to reach out to me anytime, and I'm here for any question you would like to ask.
First of all, I would like to thank you firstly for your outstanding presentation, your practical insight into the smart buildings. You know, it's like fantastic, and future of intelligent infrastructure have been extremely informative for us. We will now move out for the questions. So if anyone can, raise their hands or ask the questions to Mr. Ahmed Hamdi. Meanwhile, I was having one doubt actually, how the system will defect before alarm is triggered, the fault detection.
Okay. So let's speak about, for example, a pump. This pump, I can measure exactly the ampere it's using.
Okay.
I can measure the vibration. I can measure the sound.
Yes.
And on these parameters, I can know exactly how the performance of the pump is ramping down. So I can
Ah,
start to know exactly when it will fail.
okay, 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 okay.
But
Oh,
again, this is the value of an AI on top of this solution. Because simply, if I'm having a normal operator, this operator will not follow these small, tiny patterns 24/7. But
okay,
having AI identifying AI agent, this agent will work only to monitor the performance of the pump through oscillation, ampere, sound, vibrations. So it will be an AI agent monitor these parameters 24/7. So I can know exactly how the performance is degrading and I can know exactly when it will fail. And
okay,
even this will start changing the way you sequence the pumps. Because in every single sequence of operation, you will find like we are counting hour of operation for each pump. And based on the hour of operation, I start the choose which one will perform and which one will be a standby to assure
okay,
that all of them are almost running the same number of hours.
okay,
Right?
okay. Yeah,
This is the
perfect.
current one. But
Okay,
sometimes, if I'm running pump number 1 and 2 in the morning, pump number 3 and 4 in the evening.
okay.
After 1 year of operation, do you expect that the pump which is running in 50 degree in the 12 noons will be
Yes,
exhausted as the pump running at the evening 12 EM? Definitely no. They are running the same number of hours, but
yes,
the performance is completely different.
yes, obviously.
So this is how the system is really calculate how the performance of the equipment is dumping down.
Okay, okay, okay. Perfect. Perfect. Thank you, Mr. Hamdi.
Thank you so much. It was
Yeah,
my pleasure.
yes, welcome. If any other have any doubts or anything, like we can also. I hope Mr. Hamdi has shared his email also. If he can, if someone can contact him through email.
I will put on the chat here.
Yeah. And also, thank you once again. And I would like to sincerely thank each and every participant for joining today's webinar and making the sections interactive and successful. Before we conclude, I have also exciting announcement for future. UE MEP engineers community is planning for our next technical workshop combined with an exclusive factory visit where participants will gain practical exposure to engineering systems, manufacturing processes, and have the opportunity to network with fellow professionals. Obviously, we can meet and greet together. Registration links and event details will be shared in the group very shortly through LinkedIn official website also. So be connected with us and don't miss this opportunity. If you haven't already, please scan the QR codes. I will just share on the screen. Uh, and thank you once again for the speaker and our participants and UAE MEP Engineers community team will for making today's webinar a success. All our team members, admins, and our IT team mainly. And we look forward to seeing you once again in the upcoming webinars to all the participants and these things, technical workshop, factory visits, and networking events. Until then, keep learning, keep sharing, and keep creating impact. Thank you for today. If anything,
Thank you so much.
welcome, welcome, welcome. Okay, so we will end the chat today here. We'll meet in the next webinar and technical seminars. Okay.
Okay, thank you.
Okay, welcome, welcome,
Thank you.
welcome.